Hey, what's up, guys? Let's go through this trig question. Now, main point for this video is the idea of an altered domain. Basically, we've been doing questions that were for the domain of 0 to 360, but now we have different domains. So in this case, 0 to 720. Okay, so remember like our sine graph, or like any trig graph for that matter, it doesn't actually stop. It doesn't actually just stop at 0 to 360. It actually continues on, and even backwards as well. Okay, so just give depending on the given domain, right? So like in this case, like a given domain, we're going to solve our question. Okay, so it's very easy once you understand it. So let's just answer it like a normal question. So sine x is equal to a half. So we know that x is equal to 30 degrees, right? And if I draw up a little all stations to central, sine is positive in this one and this one, right? And this one's theta, 180 minus theta. So we have this. So this is how we would normally calculate it, right? But since we have an extra 360 degrees, like we have another full turn, all we need to do is just add 360 degrees to the two answers that we already have. Okay, like add 360 and add 360. Okay, so just for the sake of writing it kind of perfectly for each line, I'm just going to write 30 degrees plus 360, right? So that's that first angle plus 360, and also like this. Okay, and the second one plus 360. Okay, and so yeah, we should have these answers. So x is equal to 30 degrees, 150 degrees, 390 degrees, and last one is 510 degrees. Okay, so just answer it like normal, and then we're just going to add an extra revolution to each of those answers. Okay, and I'm just going to show you one more. I talked about how we can go in the negative direction, right? How sine goes infinitely in both directions. So we have the domain 180 and negative 180. So let's try to solve this. So square root, we have plus minus 1 on root 2. Now, plus minus is every single quadrant, right? It's all 4 quadrants. So all stations to central, theta, 180 minus theta. It's every single quadrant since it's plus minus, and our principal angle should be 45 degrees, right? So again, I would recommend just try to solve it like normal. So 45 degrees, 180 minus 45 degrees, 180 plus 45 degrees, and 360 minus, let's move this freaking guy over, minus 45 degrees. Okay, and if we calculate it, it's 45 degrees. What is this? 135, 225, and 315. So we have these answers, but only some of them are good. Like this one, 45 is definitely in this domain. 135 is in that domain. But these guys are not, right? They are outside the domain. So to fix it, let's just take off a revolution, okay? Because that answer is good, but it's just not within that domain that we want it in. Okay, so basically theta is equal to 45 degrees minus 135 degrees, and 225. If you go 225 and you subtract 360 degrees, we actually get negative 135, and this one we get negative 45 degrees. And these are the 4 answers that are necessary, and it's the correct one for this domain. Okay, and again, great thing about maths is if you're ever unsure about some of the answers that you got, just chuck them in. Like if you put it into the calculator, you should get the answer. Okay, so yeah, so that's how we do altered domains. Thanks for watching, and I'll see you in the next video.